Hi everyone, welcome to what day is it? The August 15th, 2018 API Machinery SIG meeting. I'm back from paternity leave, and the first half of this hour we were going to do a joint discussion with the multi-tenancy group. I see Mike is on the call, David Opp is on the call. David, is everyone you were hoping to be here?
We didn't have we invited everyone from the working group who was interested in the topic.
Is he really quiet for anyone else?
Yeah, David, you're super quiet.
I don't know, can you hear? Is it any better now?
Yeah, we can sort of understand you, but you're very quiet.
Okay, sorry. Sometimes it takes a minute before the microphone adjusts. Mike is the most important person to be here, and we invited the other folks from the working group but I don't know exactly who will show up and who won't. So as long as Mike's here, I think that was the main.
Okay, great. Well, let's get started. Mike, do you want to kick us off, or David?
Mike originally brought this issue to the working group, so maybe we can let Mike introduce it, and then I can fill in some of the conversations that we had at the previous meeting if he doesn't cover that.
Okay, great. And Joe has volunteered to take notes, so.
Yep. I'm just going to do them in line here.
All right, thank you.
Oh, there you go. Okay, I was about to say we can't hear you. Go ahead.
Yeah. Okay, so yeah, I think this is not actually a new issue, so I'll try to represent what I understand the previous discussions to have covered as well. But what launched me down this path is, as you guys know, I'm working on building a control plane. I consider my project to be building a control plane for something not Kubernetes, using Kubernetes API Machinery. Specifically, I'm focused on building an SDN for a fairly traditional infrastructure sort of infrastructure as a service system. I mean, the whole system includes virtual machines, virtual networks, virtual storage, all the usual stuff. I'm kind of focused on the SDN in particular, but the concern is really for the whole thing. And this is a multi-tenant service, as infrastructure as a service typically is. So fairness is a concern. Obviously, we've got our own schedulers for the managed resources, and so the issue is not are our schedulers fair. The issue I'm bringing to this particular forum is our control plane fair? So that is, can one tenant make the control plane so busy that, a subset of the tenants make the control plane so busy that it doesn't give a decent amount of attention to the other tenants. So that's, that's just the basics of the problem. In the previous discussion in the multi-tenancy work group, it mostly centered on the long-standing issue of exactly how do we define a tenant anyway. I think I see Craig here. He brought one of the more challenging scenarios, which he's written up and posted to the multi-tenancy working group mailing list. I think actually, Craig, that your scenario can be handled by a fairly simple concept of multi-tenancy as long as it allows controlled access between tenants. So yeah, your concept, your situations won't work with total isolation, but if there can be controlled access, both in terms of users accessing the API objects and stuff in the data path in the network being able to access stuff, as long as the relevant parties can control that in the desired way, I think that can cover your scenarios. So basically,
let's that's a lot to digest already. Hold that thought for a second. I want to ask a question, which is the thing that you brought up, fairness. Is that really I mean, it could be and it should be a concept in a multi-tenant system, but arguably we'd also want fairness between namespaces or over service accounts, and I'm not sure that either of those map to a tenant concept.
So yeah, fair point. Right, I should back up and be more comprehensive. Right, we also discussed issues about protection against bugs or failures. right? So even in a single tenant system, there's a concern with if something goes wrong in a controller, for example, we don't want that controller overloading the API servers or the etcd servers. On that topic, I think we centered on the idea of using rate limits, engineering rate limits to protect against controllers that go bad. But rate limits are not really an adequate solution for fairness, because for tenants, you don't simply want to divide the total capacity amongst the tenants and be done with it and have no possibility of statistical multiplexing or anything. You want the rate limit set higher than 1/n of the capacity.
Yeah, and fairness on its own isn't enough, because you don't want to be fair between a bunch of components that are hogging stuff and a bunch of critical components that are that also need to send a high rate of QPS, right? Like you need to prioritize an additional to being fair, and you probably need to wait among namespaces, so bigger namespaces get more QPS.
And also I think another distinction you can make is trying to protect between denial of service and trying to enforce some quantifiable guarantee, which I think is a little different. I think the first one has a more squishy and probably easier to implement definition, just making sure everybody gets some service versus having a very sophisticated prioritization and allocation scheme where if I pay twice as much, I can get twice as much of the scheduler CPU time, and I'm guaranteed a scheduling QoS of 5 pods per second, and you get 10 pods per second. I think like that I think is pretty difficult. I mean, you could in theory implement that, but a simpler starting point might be just say we're going to prevent denial of service, and then we can internally kind of define that however we want and change that definition over time, and, and not have to enforce it quite as precisely as the other way. Sorry.
Yeah, I'm a little surprised that we're talking about fairness. That's not what I was expecting the conversation to be about, because that's not what I think of when I think of adding a tenant concept. And I think we can add fairness to our existing system without adding a tenant concept.
Well, just to be clear, that nobody the adding a tenant was kind of an orthogonal, and a tenant concept was kind of an orthogonal discussion. It came up in discussing this because you have to define what are the principles or entities that you're isolating. But I don't think we have we can define pretty much anything as the isolation domains. We can say it's namespaces or service accounts, or I mean, I think one example that was brought up when we talked about this last time was the event rate limiter, which lets you choose whether you want the rate limiting to be, I think it was for events to be, I think it was global or namespace, or was it service account? I think, or
yeah, you can do it by subject as well. Are you using that as an example of what you would like to have a rate limiter have flexibility on? I guess I'm standing back and saying, what decisions are you trying to make at what level with what information, right? And there are lots of different options for how you manage that, and obviously a webhook based rate limiting decision defeats the purpose of your rate limiting decision. So
sorry, why do you say that? Are you saying because it's too late in the request path?
Yeah, you've already used significant resources at that time.
Yeah, right. If you've made that request, you've already
right. So I completely agree with David's comments. If I guess different people read more or less into the word fairness. I was not trying to talk about something very precise. My concern is simply that as a provider of infrastructure as a service, I really don't want some of my, like a busy subset of my customers locking out more or less the rest of my customers. So it's more like a denial of service issue, and not deliberate, just even, accidental. I just don't want to let, there to be if some of my customers are really busy, I don't want that to lock up my other customers.
Yeah. I think that's a very reasonable request from the control plane. And in fact, there's long-standing, probably filed by Brian, issue on we need prioritization and or we need fairness, prioritization, and there's a couple other things in the same group of things that we need. Yeah, so I was expecting when I hear people talk about multi-tenancy, some people just want their workloads to be completely isolated. Some people want no visibility between tenants. Yeah, so I was expecting.
Sorry, no, this wasn't. Sorry, maybe I didn't. I didn't introduce the topic when I mentioned it to you the other week properly. We were not looking for a general multi-tenancy discussion, although we should have those in the future. This was really just focused on the specific issue of what Mike was calling fairness, or what you call DOS prevention between tenants, or what have you. But yeah, kind of all those other parts of multi-tenancy are interesting and things we've been talking about in our working group, but weren't really the topic we were planning to bring to you guys today.
Gotcha.
Right. The problem is, the connection is, as was mentioned, we need to have a definition of the entities that we're providing fairness between, or preventing DOS between. And in particular, I don't have a really strong opinion, but what I need is that these entities will line up with my customers, in more or less, in some useful way. So it seems to me like namespace is the most obvious candidate here, but it doesn't necessarily have to be namespace. At the end of the day, I just need something that can effectively represent my customers to solve the real problem I have.
Yeah, I think namespace or service account are the obvious places to add it in the.
I don't think that would be sufficient if you were trying to add a rate limit for subjects to the API server, right? It allows you to express one dimension of things you are operating on. But if we look at the choices we made when we very first made authorization, we looked at what is cheap information on a request, and then how can we describe a policy around that.
Right. I think that's quite reasonable to be a little bit more general here. Like you said, pick up whatever's cheap, be able to discriminate on it.
Yeah, that makes sense. There's additional, you mentioned controllers, and like making controllers for whatever this grouping concept is, be able to fail independently. That's actually, I think, a harder problem, at least as hard of a problem as adding the some sort of fairness rate limiting into the control plane.
Sorry, can you explain what that problem is?
Yeah, because right now all of our controllers run in mega binary, and they run over all namespaces. In order to get the property where a controller can fail for some tenant or grouping construct and not fail for others, I think the controllers need to be shardable in some way.
Well, not necessarily. So first off, your controllers are not my controllers. But we might still do some grouping. But still, if the fairness or DOS prevention is done in the admission pipeline in the API server, it can still discriminate amongst requests coming from the same mega process.
So I guess I'll go on record as I don't think admission is an appropriate spot to do this. By the time you get to admission, you've already paid the cost of interpreting the entire payload. And
was anyone arguing that we should do this in admission?
He just mentioned it.
Well,
Sorry.
I brought it up the event rate limit example earlier, just because when we were talking about what are the subjects that you could use as the tenants, and I was just mentioning that there was, that gave us an example of where people had made a decision about who could be the tenants. But I guess my question would be, I guess we have several topics on the stack now, but just to take this one, where would you put this? Like the QPS rate limits are in the client, but we don't want to trust clients to be well behaved by kind of.
Yeah, we got to get the QPS limits out of the client. I think I'm with David on this, and we should make it judgeable off of cheap information, and it should happen potentially like at the same time, before or immediately after the auth Z step with the same information.
So Daniel's point, though, about how would you achieve fairness in a controller to begin with, regardless of what the API server did, I think is a valuable point, right? If because of the way the controllers are structured, it is possible to starve one.
Yeah, and if one customer,
Wait, can you clarify that? What starvation are you talking about?
controllers themselves have a QPS rate limit. So if somebody is busy enough to cause the controller to send lots of requests, it might exhaust the QPS on behalf of other folks who might want to use the controller services.
So the rate limit. So so this is self-restraint in the client, and when the limit is hit, what happens?
The client can't send requests faster than that limit, so a queue develops in the client.
So all the requests are queued. They're sent eventually at the rate limit.
Yes, but if the queue allows, like if somebody's generating events at a far larger rate, actually, does it work out the way? I think people who generate
some deduping will happen when if you are generating events on a resource that a controller is going to look at, and it is currently backed up, those events will dedupe. So you'll get some reduction there, but you can certainly take more than your share if you are busy on a resource that the controller is watching.
My broader point was we also have a problem with our controllers, maybe not your controllers, Mike, but with our controllers where eventually we're going to get clusters that are big enough that the controllers don't all fit on one machine, and we have no sharding strategy at the moment, right? I think there is a natural sharding strategy, which is to assign particular namespaces to particular shards of controllers running the same thing, and we could potentially also shard by. I'm not sure if service account makes sense, but if we had a tenant concept, that would also make sense.
But even without sharding, I thought your point was that we would have to make our existing controllers aware of tenants and do this kind of internal fairness in order for the overall system to have that property, even if they all fit on a single node. I mean, right? I thought it was just, isn't it like the when we talk about control plane fairness, it's not just about the API server. It's also we would have to make some changes to the scheduler and the controllers and the controller manager so that they can't they don't become they don't.
Yeah, you'd have to make the controllers which includes scheduler as a controller. You'd have to make the controllers have their own notion of fairness and sharding them into and just running a shard for each grouping is one way of doing it. It may be an expensive way of doing it.
Yeah, that only makes sense if you have support on the API server for actual sub-selection of namespaces.
I think
which we do, right?
Not an efficient one. If you do that, you'll just toast the server worse. It resolved by stepping through everything.
I think API server itself needs to export needs to have a sharding concept that you tell it how many you want, and it divides up the namespaces into shards and lets you watch each shard independently.
But anyway, I'm not sure this is a practical strategy. Like, think about like a software as a service provider who's supporting like 1,000 clients. They might not all be active at the same time, but like running on a cluster simultaneously. You're not going to run 1,000 copies of the controller manager, 1,000 copies of the scheduler. I mean, I think that the practical strategy is to make these controllers be tenant aware, right?
I think I think like the API server should probably divide it up into a separate shard per thing, but you should be able to group them so that you run the number of shards that you want based on the resource footprint that you want to have, and then each controller manager gets multiple shards.
It feels like we might have drifted a little bit from the initial topic, right? Like if the initial topic is about do we want to have better rate limiting in the API server, then
sure.
I think Mike's has had a valid point earlier, which was like rate limit, and he brought this up when we talked about it in our working group. Like rate limit may not be the right concept because it doesn't give you an easy way to oversubscribe. Like if you have two users in the cluster, you don't really want to limit them each to 50% because you want something that's, I forgot, there's like some fancy word, work conserving or something. Like you want something so somebody can use the Slack resources when the other one isn't.
I think we'd actually look at what we do for pod resources. Like we've got a request and limit model. I think we might look at something like that.
I think that's still too crude. David was right. David O was right. The word is work conserving, and it's a concept in queuing systems where you say, look, you want your controls to not waste anything, so that the guys who are asking for work are able to use up the system, even if there's a bunch of guys who are not asking for any work.
Yeah, it might be worth discussing whether we expect our system to be oversubscribed or undersubscribed.
Oh my gosh, is that even a question?
Well, yeah, like let's go back to the SaaS example where you have let's say 1,000 tenants in a cluster, and you have some resource, and then let's use the limit and request model. When I say resource, I mean control plane. Let's say scheduler or CPU time or something. Like how would you set the request and limit in a sensible way in that case?
Go ahead.
I think only when the whole system is close to be oversubscribed, then you start to think about enforce the limit. So
I will point out we have 4 minutes left.
Yeah, I'm still chewing on I think if your control plane is oversubscribed, somebody's going to have a bad experience.
I would agree, but at the same time, even if you don't plan to oversubscribe, unless you make it easy to migrate a tenant from one cluster to another, I think customer growth will naturally lead you to oversubscribed clusters.
Or you have to have dynamic limits and crank them down as customers grow.
Yeah, I mean, clearly we don't want to waste resources, and we need to tolerate at least brief periods of oversubscription.
I'm sorry, oversubscription might not be the right word. I think statistical multiplexing is more like the right word, or work conserving, right? The concept is you've got a cluster with a certain capacity. If you've got 1,000 customers, but only 300 of them are busy now, you want to let all those 300 use all your resources.
Yeah, okay, yeah, that makes lots of sense.
Yeah. So in that case, it's hard to know what a sensible rate limit would be, because obviously you don't want to just give each one 1,000. That would be too limiting.
Yeah,
that's something to think about. I don't think we'll solve this problem in the 3 minutes we have left, but that's one thing to consider in designing this. But do we have are there any kind of design? Not
so I was about to say the outcome from this, maybe we should see if there's appetite for somebody actually putting together a design. I think we've wanted this sort of thing for a long time. Brian has very old issues about it, but we've never found time for somebody to go out and do a design or actually start implementation. So I don't think anyone is opposed to the concept. I mean, due to all the stuff that we mentioned here, it is tricky to get right, and there will probably be a vigorous discussion on any design. But I think actually, this is probably tractable. I think we can converge on the design on this. I'm not sure if we can on the broader issue of multi-tenancy in general. But
yeah, so, that's a much larger discussion. But.
I'll be happy to put together a proposal. It's going to run into some disagreements with what I've heard. I haven't had a chance to discuss those things, but since we're out of time, I guess this is the way to proceed. Is Brian available, or anybody else to work with me on that?
I'm happy to work with you on it. Brian may also be available. I don't know, but I can help.
Yeah, I would like to at least. I'm not sure how much time I can make, but I would like to at least remain informed.
Yeah. Likewise, and I'm going to be, when I look at it, it's going to be with an eye towards, is it inexpensive to run, and does it provide flexibility on dimensions similar to authorization? Because I think those dimensions are the cheap ones that we have, and each one has proven valuable over time.
Okay, so maybe I'll do this. I'll produce a rough outline, an initial outline, enough to flush out the basic disagreements, and send it to the email. which one? Should it be the API machinery or the multi-tenancy working?
Maybe both,
Notes or B, copy both.
I don't know.
Yeah, copy both, or yeah, I'm on both lists, so I'll see it either way.
Okay, so I'll send an email with enough of an outline to get into an argument to both, and we'll proceed from there.
Alternatively, sometimes if you want a more focused discussion initially, like if you copy David Eads and myself and get a pre-flight review,
okay.
Take the whole thing.
Okay, I'll start with you and David O.
And I would include David Eads in the pre-flight.
I meant to say that. Yes. So it's David Eads and the other David, which is
Oppenheimer.
Right, and the person speaking was
Daniel Lavalamp.
Yeah. Okay, great. So I'll do you three, and we'll start arguing amongst ourselves, and we'll proceed from there.
Yeah, I think that'll be good.
Okay. Thank you.
Thanks for letting us use your meeting. I think.
Yeah, this was a lot
That's a
more
good spot.
focused and productive than I was expecting. So thanks everyone. All right, next topic, David and Marco.
Yeah. So Marco, at the beginning of summer, started a Google Summer of Code project where he was looking at the challenges that you face when trying to write an aggregated API server and provide it as a unit for cluster admins to install into their cluster. And he targeted how you manage storage for your API server in a way that you don't have to have ever-expanding buckets of storage that need management. And I guess from there, I will let Marco pick it up. His project is concluded. He's going to demo to us what we have. If you could let him share his screen.
Yeah, let me figure out how I can stop sharing my screen.
Okay, hello there. I just set up everything. Share the screen. Just let me know when I can.
Yeah.
Okay, it should be fine now. Let me try it. Okay, can you see it now?
Yes.
Okay, so hi there, I am Marco. I was Google Summer of Code student with my mentors David Eads and Stefan, who is not here today. I was working over the past few months on the etcd proxy controller, which represents a solution to the etcd storage problems for aggregated API servers. What the problem there is that if you want to get started with aggregated API server, you need to deploy the etcd cluster. You can't reuse the existing cluster because there's high risk of mutating each other data, especially if you have multiple API servers or if you want to reuse the main etcd cluster. With this project, we are using the etcd proxy feature of the etcd to create a proxy to the etcd cluster. That proxy is to a namespace or just that looks like a prefix when you watch the key. For example, the key will not be /something. In case when it is proxied, it is / the name of the namespace / that name of the key we want to use. So that way we can have one etcd cluster, but multiple users that are using it with the proxy. So what is happening here is that with this approach, you don't need multiple etcd clusters. You can use one or even the main one that you use for Kubernetes. That means you don't need to manage the cluster, the certificates rotation for multiple cluster. You can have standardized backup strategy for the one cluster. Also, it is just easier to handle upgrading and maintenance of the one etcd cluster than more of them. Today, we are going to show how this works, and I'm going to demo it to you today. So here, right now, I have the local app cluster running here that we are going to use for demo, along with the etcd cluster deployed in the etcd namespace, and it's running here. What are we going to do right now is to deploy the OpenShift service serving cert signer. It is a project from the OpenShift team that handles the certificates for aggregated API servers. So you don't have to do it yourself. But this is a project from OpenShift. doesn't have dependencies on OpenShift, and you can use it on the classic Kubernetes cluster. So we are going to deploy the Aircross for that, and it's here. And once we have the Aircross, we can deploy the cert controller that is going to handle the certificates for our aggregated API service. Okay, this will take some time to come up, but we are going to proceed with deploying the etcd proxy controller. So the first thing we are going to do is to deploy the first manifest, which creates the namespace and the service account used by the etcd proxy controller and service account used by the etcd proxy pods. So let's create it. And okay, it's done. Now that we have the service account and the namespace, the next thing we are going to do is to create the Aircross needed by etcd proxy controller service accounts to manage resources needed by the controller. Okay, now that we have the Aircross deployed, we can deploy the controller along with the etcd storage custom resource definitions that represents our need for the etcd storage for our aggregated API server. Okay, at this point, we have deployed our controller, and by default, it is running in the namespace called Kube API Service Storage. This is configurable by providing the flag to the controller, but let's see, it's running. Before we can use and create the etcd storage resources, we need to deploy the certificates for the core etcd. That certificates are the serving CA certificate and client certificate and key pair. How that looks, this is done by deploying manifests such as this one, just to find. Okay, in the config map, we are storing the serving CA cert, and in a secret type of TLS secret, we are storing the certificate, client certificate, and client certificate key. And now we are going to deploy that one so we can deploy the etcd proxies.
So just so that everyone's clear, this is the spot that a cluster admin would end up having to integrate with whichever single etcd cluster he wanted to work with, right? So this is a custom fitting sort of piece that needs to be done by the cluster admin to make use of this. And for the purposes of the demo, it's hard-coded, right?
Yes, all right.
Okay.
So now what we have deployed the etcd proxy controller, and we can proceed by deploying our aggregated API server. How that looks like? First, we need to create the namespace for that aggregated API server. For case of this demo, we'll use the sample API server, and that manifest that deploy this looks something like this. Just to find it. Okay, this one. We are deploying the namespace, service account, but also two config map and secret. So by that, our etcd proxy controller handles certificates for etcd automatically. That includes certificates generation as well as certificate rotation. How that works, when we create the etcd storage resource that represents the etcd proxy need, the certificates are being generated. Those config map and secrets are empty in the beginning, the controller, when etcd storage is created, and when it is ready to be used and certificates are generated, the controller populates the config map and the secret. So API server will mount the config map and the secret and will use that certificates to access the etcd. And we are going to deploy that for the beginning. And it's ready, but I think there's, okay, it's okay. Okay, but also we will need the Aircross for the aggregated API server. Those are default roles, but beside that, I forgot to open it. But we will need the Aircross for the etcd proxy service account to modify the config maps and the secrets. You can define that you can only modify those to be created. So right now, we are going to reconcile that roles. And that's it. Now that we have this ready, we are going to deploy the etcd storage in the aggregated API server. Let's take a quick look at this manifest. Okay, this one. Or this. Just a moment. Okay, this one. So before deploying the aggregated API server, what we have the etcd storage resource. When we create the etcd storage resource, it starts the etcd proxy to our etcd cluster configured to work with etcd proxy controller. It creates the pod and deployment that will spawn the etcd proxy pods. Each pod creates the proxy to the etcd cluster, and it uses the namespace, which is called same as the etcd storage resource. This means that as Kubernetes will take care that we can create etcd storage, two etcd storage with same names, so nobody will be able to create etcd storage and access our data. So this is one security point here that we can mention. Also, here in the etcd storage spec, we need to provide the name of the config map where the serving certificates will be stored. That's a config map we created earlier in the API server namespace. Also, name and namespace of the secret we created earlier for storing the client certificate key pair. Also, we are providing the validity of those certificates. This is by default here 1 month in the manifest. So after 1 month, our controller, the etcd proxy controller, will automatically regenerate those certificates and replace them in the namespace. Currently, API server operator have to restart the API server manually because there is no mechanism for handling this, but this is sort of work in progress, and maybe we will come up with a solution to this problem, so API server restarts automatically. Once we have this ready, we are ready to deploy our API server. So, how it looks like. This is a simple deployment manifest, but what's important? We are mounting the config map we created earlier in the secret. So, we mount them, and when we mount them, we get the certificates. So, first thing, we are specifying the etcd server. When etcd storage is created, it exposes etcd proxy over a service that have a naming schema such as etcd / name of period name of the etcd storage resource dot the namespace where the etcd proxy controller is created. In our case, Kube API server storage, and depending on your classical CVC and port. Then we have the serving CA for the etcd storage, and then client certificate key pair. This is provided by our controller and generated by it, and provided in the config map and secret we created earlier and mounted here. Also, we have the TLS set file and TLS private key that is generated by the OpenShift controller we deployed earlier on the beginning of this demo, and it will provide the API server secrets it needs to operate.
I have a question.
Okay.
The etcd sample API server, Kube API server storage service, is that service set up with like no cluster IP equals none, so that the DNS gives you all of the backends?
Yes, it will forward to all etcd proxy for that etcd storage.
So there's essentially an A record for each etcd replica?
Are you asking about how it's done for the backing etcd that the etcd proxy pod connects to?
Yeah.
It's using a list of valid names. This work here hasn't exploded it out into the individual ones. Although my memory of the etcd client is that it actually attempts to locate others, maybe through a public peer listing.
I see. Might be interesting. Like our services have this feature where if you set them to cluster IP, but say cluster IP is none, capital N, then instead of giving you a cluster IP, it will the DNS system publishes a record for each pod that backs the service. So it's if you only have like 3 replicas or something, that's a great way to tell the client about all 3 of them. If it's that.
Yeah, but that's not what's happening here, right? If I understand correctly, this is what he's showing us right now in this command line flag. This is a reference to a domain name that the sample API server is going to look for just one A record from this guy, right? And that's going to be backed by just the one pod that is a proxy pod.
Yes.
You get a choice of how many pods you're going to have, but yes.
Yeah,
Yes.
it seems like to provide the full etcd properties, you'd want to have one proxy pod per etcd backend.
Usually,
Perhaps.
Because you want.
Well, or I don't know if you need that. I mean, if the proxy pods does the client behavior, which you described correctly as far as I know, right? You may want multiple proxy pods for HA, but you don't need that to line up.
Yeah, you don't need them individually associated. You just need to have multiples of them.
That possibly like it might work that way, but you'd also like the etcd client has some failover logic that may not hold if you don't have a one-to-one relationship. I don't know.
No, I think the proxy does the failover, doesn't it?
If you're running more than one of these, and the server talking to it is trying to manage failover, and if it thinks it failed over to another pod, but that one is actually still talking to the same backend as the first one, like the failover might get confused if you have multiple levels of failover involved.
Yeah. Also, I mean, you have to defend against the proxy pod itself failing.
Right. So it seems like this is something you would cascade. The proxy should fail over amongst etcd servers, and the API server should fail over amongst proxies.
Yeah.
mostly.
This is
I will.
a side conversation. I'm sorry, I didn't mean to.
It's a very good. It's a good side conversation. But I'll say Google Summer of Code project. I may not force them to do that to graduate.
Carry on.
Sadly, we had not that much time to go into age availability and that, but we try to make that as much as we can so it works.
So a quick question here. Is there any isolation between the etcd provisions? So as I understand it, you are sharing one etcd instance.
Marco, did you understand the question?
So no, sorry.
Say the Kubernetes, main Kubernetes are using the same etcd instance as other like sample API servers, right?
Okay.
And is there any protection between them, such that say
Yes.
the sample API server has some bad behavior, the main Kubernetes is not suffered from that?
Yes, because we are using the namespaces feature of the etcd proxy. So when we start the etcd proxy, for example, when you write to it, you write some key. But for the main etcd cluster, that key is prefixed, and you can only access keys that have that prefix. So you can't really access the key that doesn't have it, and it is secured from that no other API service can access other data, neither the main Kubernetes cluster maybe can access because it may have the access to the main etcd, but
so as long as there's no path traversal bug in the proxy, it should be safe from that perspective. But following up on our earlier question, what about fairness? Like is there any? Can one client send so many etcd requests that the other clients can't get a word in?
Yeah, that's what I intend to ask.
Yeah. I think that would be a case where we would try to build a layered solution where an etcd proxy was able to support the idea of a rate limit to effectively rate limit the API server associated with it. And since that API server only has connection credentials to the proxy, it can't bypass them. So this is a starting point to that. I don't know offhand if the etcd proxy already has that rate limiting option.
I don't think it does.
Yeah.
it doesn't have the rate limit.
But it could be yeah, it would be sort of a layer on top. It could be built that way, or it could be, I mean, Istio promised that, right?
Yeah, other than the load, I think say other resources like storage resources could also be, may also need to be catered to ensure the storage is fairly shared among the different conditions.
Yeah.
Anyway, please continue.
Okay, so let's continue. With these certificates in place, API server will use them to securely access the etcd and to securely serve itself. Also, we are going to create service to expose the API server and the API service to register the aggregated API server with Kubernetes API. So what we can do is to deploy that API server and to see the magic. So first, we are going to do what is happening in the etcd proxy controller namespace. Okay, we have new deployment that's called etcd period name of the etcd storage resource, and also it created a free pods of the etcd proxy. Let's see how is it working in the aggregated API server. It is running. Here we have only one pod for demo resources, but you can have however much you want of them. So let's check one more time. And now, to verify is it working correctly, we are going to create a sample Flutter resource that comes with this sample aggregated API server. And it works. So this aggregated API server uses one etcd cluster that is backed by the etcd proxy. That means you can add as many aggregated API servers you want that will use the same etcd cluster, and that means just only one is needed. This could also make it work to use the main etcd cluster used by Kubernetes if you really want that, but here we are using the dedicated etcd cluster for better security and for better, easier way to access it. So what is also important to mention here is those manifests we saw here for deploying the aggregated API server are fully static, and you can easily port them to another cluster or whenever you need it. Then what you just need to do is to deploy the etcd proxy controller and to configure it to use the correct etcd cluster. And then when you just deploy the aggregated API server, they will create your etcd proxy to correct cluster, and you're ready to use them. So this is mostly for now. There is a link in the agenda document to the repository that you can find more details on how to use that. So for now, this is it. If you have any questions, let me know. I can answer them now if we have time for some discussion. If not, you can find me on Slack or just create a GitHub issue.
Thanks. That was a really nice demo. It was good to see that it's possible for an aggregated API server author to provide a static manifest that someone can reuse without having to create their own custom manifest for every cluster they want to deploy on.
Yeah, I think this is pretty interesting. I wonder if there's like is there like an end-to-end test or something that like starts up the etcd and proxy backend? Like it'd be great if it were really smooth and easy to run.
Yeah, it turns out that Marco, do you want to take that?
No, you can. Sorry.
Okay. It turns out that his mentors are myself and Stefan, and we are a little bit picky about tests. So after his first week, he wrote an end-to-end test that runs on Travis and uses Minikube. So yeah, his repo is set up where the EDE runs and goes through. I think it's the happy path and like one error case right now.
Okay.
Yeah, there is only one case for now, and it was very fun building the E2A test with David and Stefan. It was really interesting. But yeah,
Fun or
we have tested more. they work very well so far.
Okay, cool. Looks like we're almost out of time anyway. So thank you, Mike, for the multi-tenancy discussion, and thanks, Marco, for this presentation. And I think we'll call it a day. See you all in 2 weeks.
All right.
So,
Bye, guys.
Thank you. Bye.